Let's just delete 4. Okay. So why I say you need to be careful. So now A is no longer a scalar, right? It's no longer a scalar. You need to have those dimension fit. That's why you need a transpose here to make a transpose. To make the dimension fit. Think about this. That's a very interesting question. Okay, that's the one thing, but you can check it out. Right? It still worked. And if you use this expression, I'm pretty sure that the result is incorrect. The MATLAB will give you a warning or an error. You can try it. Right? This is an error. It's incorrect. Why? Because right now we are doing the matrix operation. So that operation is incorrect one. We want to make it pointwise. That's why we need to use a dot times something. Okay? See? After the correction, that works. But anyway, let's still use that maximum. That looks better. So we dropped everything already. We dropped the if and else. We dropped the 2 for loops. Right? So let's keep simplifying. Okay. So what can we do? Of course, we can just put that A directly inside and put that B directly inside and put this I in here and J in here, right? We can just directly put it in. But what about those stuff? So that will make the codes very tedious. There is an interesting way to think about this. So why do you want to write this line? You just want to make all the diagonal entries equal to 0, right? So I just want to turn everything into the multiplication operation. So you can also do it in this way. You can also say, okay, let's make our A be, let's create identity matrix. So identity matrix, what's the identity matrix mean? So identity matrix of the size, no, just make it n. Right? So identity matrix means the diagonal entries are 1 and all the other entries are 0. So we want to make it opposite way. All the other entries equal to 1 and diagonal entries equal to 0. So that if we multiply this pointwisely on our A, we will be able to make all the diagonal entries equal to 0 and keep all the other entries be the same, right? So that's a very good stuff. Let's see if you can do that. See? The result is still equal to 8. So that one is better than that one. But the reason why I say better, because this one, you have 2A in the expression. And the expression of A is super complicated if you put everything together. So you can still write it in a single line, but it will make it long. Okay, so I don't want to do this. But that still work. I would say that still work and that still work. But just prefer the second cases. Okay. Right. So now we will be able to put everything together. Just delete this A. Seems we don't want it anymore. We just directly keep the value of A to be here. And the N, we can replace all the N by the size of I and the size of I1. So the row number of I. And this is I. So okay, let's say we just replace all the N by this. Now we can drop the N. Alright? And now replace all the I by this. So that we can drop the I. Analogously, for J, replace it by this, and we can drop the J as well. And this is A and B, right? So we can replace B by this very long expression and replace A by this very long expression. Okay, so that's why I say I prefer this this expression than that one, because in this expression, you see, you need to write the A twice and you need to write the B twice. Just the similar reason why we don't want to use this one. Okay, but that works anyway. Okay, so we can delete the expression of A and B. Right now this is A. Okay, and we can copy everything here, put it right there. So that would be great. And we can delete this A. Okay. And now can put that A inside of the sum. I know it's pretty long, but it will make your code looks really cool. It's only a single line and you can do everything. So you have an input and a single line help you do everything. Okay. See, that works. Okay, you may ask whether we can simplify this, continue to simplify this. Of course we can. So during our vectorization, there is some duplication actually. So I here, the first dimension of I is 1 to the size of the first dimension of I. Actually, you can, this is just natural expression. You don't really need that. You just let it go through all the rows of I, right? This is what you really want. Okay. Now it looks a little bit better. And you run it and still gives you the correct answer. Okay. So for that problem, the sum of all the intersections, you can use a MATLAB function with a single line to realize it.